All right, we're going to keep going with our work on solving equations that have variables on both sides of the equal sign, and we'll look at a challenge and then a real-world connection. So go ahead and read through these. You can pause the video and look at them. Give them a try on your own. See if you can make some progress on them. But let's go ahead and get started. So the first one on the left side, I am thinking of 5 consecutive odd integers. Okay, and their sum is exactly 5 times the middle of the 5 numbers. What's the largest of the 5 numbers? All right, so that has some complexity there. We know that certainly there are 5 numbers we're dealing with, but they're consecutive, so that means in a row, but they're odd also. So for example, 3, 5, 7, 9, 11 are both consecutive and odd. And then their sum is 5 times the middle of the numbers. Okay, and then we're looking for the largest. Okay, so there's a lot of stuff going on here. Let's define my variable, and I'm going to go a little bit rogue here. I've often told you to simply define your variable to be whatever the question is asking, and in this case the question is asking for the largest, but I think it's a little makes a little more sense to define my variable as let's let x be the smallest. And if we can figure out what the smallest number is, it should be easy to figure out what the largest is. And so then let's turn all this into a mathematical sentence. And so one thing, whenever you're dealing with consecutive numbers, if we're just dealing with plain old consecutive numbers, we have x and x plus 1 and x plus 2. But that's actually not what we're dealing with, and that would keep going for however many numbers we want. We actually have x plus 2, because we want these numbers to be odd, and x plus 4, and x plus 6, and x plus 8 equals, and they're going to equal 5 times the middle number. So the middle number here is 5 times x plus 4. And let me explain a little bit more how we know that these will be odd numbers. In fact, we don't, okay? But we know that they will differ by 2. Okay, so we want to, when we get our final answer, we want to make sure they're odd, but the way we have an equation set up right here doesn't guarantee that they're going to be odd. So let's say our smallest number is, I don't know, 13. This would be 15, this would be 17, etc. Okay, so we do know that they're going to be consecutive, and we're hoping that they're going to be odd, but that's not guaranteed. We're going to see what the answer turns out to be. Okay, so let's simplify both sides. On the left side, we have a total of 5 x's, and then a 2, and a 4, and a 6, and an 8. So let me make sure I'm adding that up properly. That adds up to 20 equals, and then on the right side, oh wow, look at this, 5x plus 20. Okay, so what's going on? I think you can see that we have an identity. So what I said earlier is that this should work for any value of x. So let's try it. Let's say we have x equal to these numbers. Is that, if we were to add all those up, is that going to be equal to 5 times the middle number, which is 5? So this is 25 on the right. 1, 3, 5, 7, 9, it does. It equals 25. And so this should work for numbers that aren't consecutive odd numbers as well. 2 plus 4 plus 6 plus 8 plus 10. That should equal 5 times the middle number, which is 6. And it does, it checks out, it works to 30. Okay, so we have an identity in this case. So in some ways, we don't have enough information to actually figure out what the answer here is to the question that is being asked. But also, there are an infinite number of answers to this question. So any string of 5 consecutive odd integers should sum to exactly 5 times the middle of their 5 numbers. That's a pretty cool problem. I bet you could figure out a magic trick with that. Maybe I'm thinking of 5 numbers, add them up, something like that. I'll let you work on that. Let's look at the real-world connection problem next, and this is another true story for me. I went to college in Maine, and some friends and I went to a U2 concert in Boston in 1993. Tickets to the concert cost $45. We needed to rent a van to drive down from Maine. The van rental for the day was $30, and food was going to be $10 per person, and tolls and gas we estimated would come to about $60 total. And we wanted to keep the price to $75 per person. And so once again, as I often say, let's define our variables by having our variable answer that question. How many friends did I need? Okay, so let's have x be total number of people. And presumably one of those people is going to be me, and so we can say x minus 1 is going to be the number of friends, but we can do that at the end. And let's write an equation here. And for me, it often seems like the equation is easiest written sort of backwards from right to left. So we have a whole bunch of stuff equal to 75x, $75 per person. Okay. And what do we have to include? We have $45 per person per a ticket. The van rental, that's just a flat fee, not a per person fee. Food is going to be 10 per person. And tolls and gas were 60 total, so another flat fee. Okay, so it looks like we have our equation set up. Let's go ahead and solve it. Well, let's simplify it first before we start solving. So we can simplify the left side. We have a 55x plus 90 equals 75x. All right, and looks like we can subtract 55x from both sides to clump the x's over on the right side. And so these guys cancel. We have a 90 is equal to 20x. And we can divide both sides by 20. And I already am thinking, am I going to get a decimal number of people, a non-integer number of people? Let's see what happens. So we have x is equal to 90 over 20 is 4.5. Okay, so I need 4.5 total people. So let's not deal with half people. Let's bump it up to 5 and make it a little bit better. That additional half friend will help pay for some of the gas and tolls and van rental. So we need 5 total people, which means I need 4 friends to come along. Okay. It was a good concert, by the way. I still remember it. We had a good time. Right, and that's a good place to stop right